So let's have a go at the example of a light wave moving from air to glass. And before trying to draw ray diagrams where we draw the waves as these arrows, these rays, we're just going to remind ourselves what refraction is again. So let's start with this light wave which is coming from air and see what happens at the boundary. We know that it's going to change direction at the boundary, and so it might do something like this, where we have drawn the ray here going from air into glass. So we know that when the wave reaches the boundary at an angle, it's going to change direction. But there's a problem with these diagrams that I've been drawing so far. It's hard to get any numbers from this diagram. It's hard to look at it and say, oh, the direction changed by this many degrees or something. The kind of wiggly lines that they help you to remember that what you're talking about is a wave, but they make it harder to work out some of the maths, some of the numbers. So let's instead show the same situation, but let's do it using a ray diagram. So let's imagine this is air here and this is glass. And let's just see how much more simple this picture is and how much clearer it is. So we just have this one line on with an arrow on it, and this tells us that we are looking at the incoming wave. And if we wanted to, we could actually get our protractor out and quite easily measure the change in direction of this wave when it's refracted. And so here, of course, is our refracted wave. So there's a few terms, a few special words that we're going to want to use when we talk about ray diagrams. To start with, the dotted line on the ray diagram is called the normal. So we're talking about this black dotted line here. So let's just label this as the normal.
Hey guys, to continue watching this video and unlock hundreds of other super concise and exam board specific GCSE physics and combined science videos, just click on the Snap Revise smiley face. Join me today and let's make physics at GCSE a walk in the park.